Okay, this is the second video for the Unit 3 test review. These are the problems that are on the back of the review. We are now factoring completely. So what I want to look at in problem number 6 is that I have a polynomial written in standard form. Notice the powers, 3, 2, 1, a 0 power. So it's in standard form, but I have 4 terms. So when we have 4 terms, remember we either factor by grouping or we use the box method. I'm going to look at the GCF for those 4 terms. 3 and 2 don't have any factors in common, so I don't have any numbers that I can pull out other than a 1. And let's see, the 12 back here at the end doesn't have a V, so our GCF is a 1. So first thing we need to look at is our GCF is a 1. When I look at all 4 terms, I see that the GCF is a 1. So what I'm going to do is I'm going to do this first example with grouping. When I do another one a little bit later on, I'll do it with the box method to review that. But I'm going to do grouping on this one. So the grouping method, once we've looked for a GCF and there isn't one, or there is one, we pull it out. The next thing is we group them, the first 2 in a pair of parentheses, and I group the second 2 in a pair of parentheses. But be careful with those signs. If you're making mistakes with the signs, then use the box method because students make fewer mistakes that way. So if you want to, go right to the box method. You'll get the same answers that I get out of this one. Notice what I did. When I grouped here, I put a plus sign. The other option is you do a minus sign in the middle right there, but then that changes both of these to positives. That one and that one both have to be a plus sign. You really have to be careful with those negatives. Okay, with this technique, what I'm going to do next is look at the first group, just these first 2, the 3v to the third and the 2v squared. I'm going to see that their GCF is a v squared, and I'm going to pull out that v squared. Okay, so the v squared comes out to the front, and what we have left is 3v plus 2. The next group, our GCF is a 6, but I need to also pull out the negative, so we'll pull out a negative 6. And then 18 divided by 6 is 3. Negative 12 divided by negative 6 is positive 2. Notice the sign changes. Double check and make sure that if you distribute, you get back what you started from. Negative 18v minus 12. Yep, it works. And 3v to the third plus 2v squared. Yep, it worked. Okay, so now what I have is I have this common binomial factor 3v plus 2. My next step is to take that common binomial factor, pull it out, which means bring it out to the front, but keep it inside of parentheses. And then my other factor is v squared minus 6. And we're done. If you don't like this method of grouping, use the box. You will get the same thing. Okay, problem number 7. First thing we're going to look at is our GCF is a 1. So is our leading coefficient. It's a 1. Right, but our GCF is a 1. So what I'm going to identify is my A, which is the coefficient of x squared, B, which is the coefficient of x, and C, which is the 28. Okay. Then I need to calculate A times C. Calculate A times C. 1 times 28 is just 28. I now will look for a factor pair of 28 that adds up to negative 11. Negative 11 needs to be the sum. That's what they add up to. So I need a factor pair of 28 that adds up to negative 11. So I'm going to look at my factor pairs of 28. Now notice if I'm going to have a positive product and a negative sum, I need both of these to be negative. So 1 and 28, but they would both have to be negative to get a negative sum. That is too big or too far from 0. It's negative 29. 2 and 14. Nope, that's negative 16. Is 28 divisible by 3? Nope. Is it divisible by 4? Yes. 28 is 4 times 7. Negative 4 times negative 7 is positive 28. Negative 4 plus negative 7 is negative 11. I have found my factor pair. Recall that our next step of the process is to rewrite the middle term, that negative 11x that I have right there in the middle. We're going to write it as negative 4x minus 7x, so that I've rewritten my polynomial to have 4 terms instead of 3. Now I can either group or use the box, and I'm just going to go ahead and use the box. So down here I'm going to draw the box, and I'm going to put my 4 terms in this 2 by 2 box. So there's my x squared. I'll put my negative 4x over here, my negative 7x right there, and my positive 28 should be in the lower right corner of the box. X squared gets the upper left, 28 gets the lower right. Remember the technique. We now look at each row and column and find the GCF. So the greatest common factor for the top row is x. For the bottom row is, well, there's a negative in front of that first term in the row. So I pull out a negative and I find the GCF of 7x and 28. It's 7. Okay, let me switch colors here just for a second. Because now I'm going to find the greatest common factor for the first column. X squared and negative 7x are both divisible by x. And on this one, that second column, negative 4x and 28. Bring out the negative. 4 and 28 are both divisible by 4. Don't have an x in common because the 28 doesn't have one. Okay, then my final answer is going to be x minus 4. Remember, I find the factors on the top and on the side. So x minus 4 inside one set of parentheses, and then x minus 7, the other factors over here, in another set of parentheses. And we are done. And you can check your answer just with your box. X times x creates the x squared. Remember, this is a multiplication table. X times x is x squared. X times negative 7 is negative 7x. X times negative 4 is negative 4x. And negative 4 times negative 7 is positive 28. And we are done. And I'm going to switch back, I think. Well, let's just spread for a minute. Okay, so problem number 8. First thing I'm going to look at is, do I have a GCF? And in this case, I do. 21 is 3 times 7. 54 is 3 times 18. 54 divided by 3 comes out to a whole number. So we've got a GCF of 3. We're going to pull that out first before we do anything. Remember, the first step of factoring is pull out the GCF. So 3b squared divided by 3, negative 21b divided by 3, and finally negative 54 divided by 3, which is going to be negative 18. Okay, now I'm going to identify the a, the b, and the c for the polynomial in the parentheses. So in front of the b squared, I have a 1. In front of the b, I have a negative 7, and the constant term is negative 18. Negative 18. All right, my next step is to calculate a times c for the stuff inside the parentheses. So 1 times negative 18 is negative 18. I need to find a factor pair of negative 18 that adds up to negative 7. So I need a sum of negative 7. Remember, b is the sum. Is what I need for the sum. So I'm going to list my factor pairs of 18. I have 1 and 18. I have 2 and 9. I have 3 and 6. Make that 9 a little more readable. And I think that's it. But in order to get a negative product and a negative sum, to get a negative product, one of these has to be negative. But if the sum is negative, the negative is going to have to live on the larger of these. So let's check the sum. 1 times negative 18 is negative 18, but 1 plus negative 18 is negative 17. So I'm not getting the right sum out of that one. I'm looking for a negative 7. 2 plus negative 9 is a negative 7. There's my factor pair. Okay, so I'm going to go ahead and draw the box. I'm just going to go down here to the bottom all the ways and draw a box. So I'm going to do a 2 by 2 box. I'm going to put the terms b squared. Constant term gets here. And what do I put in the other two? Well, in the other two, I'm going to realize that negative 7b is the same as 2b minus 9b, right? 2b minus 9b. That's what we're using this factor pair for, to take the middle term and split it into two pieces. So I have a 2b and a negative 9b that add up to negative 7b, right? That's what we use that factor pair for. Now we find the greatest common factor for the top row, for the bottom row, for the first column, for the second column. And then I'm going to finish it all up. Don't forget that you had a 3 out in the front to begin with. And my other factors now are b plus 2, because this one's a positive 2, and a b minus 9. And we are done. That is the close of the parenthesis there. Okay, let's look at problem number 9. I think I'm going to switch back to my blue. Kind of done with the red. I'm switching back to blue. Okay, so 3x squared plus 11x plus 10. Here we are right here. So look for a GCF. 11 is prime and so is 3, so the GCF is a 1. I'm going to identify the A, the B, and the C. A is 3, B is 11, C is the 10, right? C is the constant term. We're going to calculate A times C. So A times C is 30. I need a factor pair of 30 that adds up to 11. So since my product is positive and my sum also needs to be a positive, you can list all the factor pairs: 1 and 30, 2 and 15, 3 and 10, 5 and 6. That sum is 31. 2 plus 15 is 17. 3 plus 10 is 13. 5 plus 6 is 11. There's my factor pair, 5 and 6. Okay, so I'm going to go ahead and draw a box. Well, maybe I'll write this out first. I'm rewriting my polynomial as 3x squared plus 5x plus 6x plus 10. That's really what's going on. If you don't write in that step, that's totally fine. You can do your box without it. But we need to understand what's happening or why this is working. What's happening is we're taking our polynomial that had 3 terms, we're rewriting it as a polynomial that has 4. 2 by 2 box, and inside the box we have 3x squared, 5x, 6x, and 10. Just these 4 terms up here are in our box. Okay, GCF for the top row. For the bottom row, 6x and 10 have a common factor of 2 and nothing bigger. 3x squared and 6x, so that first column is 3x. Second column is a 5. I'm going to double check with my multiplication to make sure this works. 3x times x is 3x squared. 3x times 2 is 6x. 5 times x is 5x, and 5 times 2 is 10. And then when I add those 4 terms, 3x squared plus 11x plus 10, it's going to work out nicely. So we're going to finish it up by writing our answer. It's going to factor as 3x plus 5. That's from the top. And then from the side, we have x plus 2. That's this over here. That's our other factor. And we have our original polynomial written as a product of 2 simpler factors. We took our polynomial degree 2 and wrote it as a product of 2 polynomials of degree 1. So we have simplified or written it as a product of simpler pieces. Okay, number 10, 11, and 12. Okay, number 10. 4 terms. Notice none of them combine. So we are going to divide out a GCF. Which is a 3. So let's pull out that GCF. We have 3x to the third minus 8x squared minus 21x plus 168 divided by 3 is, calculators, drum roll, 56. Okay, I'm going to use the box on this one. So I'm going to factor this 4-term polynomial using the box. So this one I'm just going to go right to the box. First term gets the first square. Last term gets the last square, and the other two doesn't really matter, but I'm just going to put them in order. I usually fill in the top row first and then the second row. And if you do it that way, you're going to get your last term in the lower right-hand corner. Okay, GCF for the top row, GCF for the bottom row. 21 and 56 are both divisible by 7, but I need a negative because this is a negative 21x. First column, 3x. Second column, negative 8. 56 is 8 times 7. Okay, now we're going to write out our final answer. Don't forget that 3 that we pulled out at the beginning. My other factors are 3x minus 8 and x squared minus 7. Let me pretty that up a little bit. And we have it. If we multiplied these 3 factors back together, we would get right back to where we started from. What we started with and what we end with, they are equal to each other. They're equivalent expressions. They're equal. Okay, we need to understand that. Problem number 11. Look for a GCF. Oh, 17 is a prime. GCF is a 1. A is 6. B is negative 17. C is positive 14. Positive 14. Oops, negative 14. Sorry, that's a negative 14, right? So C is negative 14. So what I'm now going to do is calculate A times C. 6 times negative 14, which is, calculators are awesome, negative 84. I need to find a factor pair of negative 84 that has a sum of negative 17. I need 2 numbers that multiply to create negative 84, but add up to negative 17, right? So let me list my factor pairs of 84. I have 1 and 84. 84 is divisible by 2. 2 times 42. 84, is it divisible by 3? Yep. 3 and 28. Calculators. 84 divided by 4 is 21. And 84 divided by 6. Oh, why did I skip 5? Because 84 is clearly not divisible by 5. To be divisible by 5, you have to end in 0 or 5. 84 divided by 6, though, is a 14. Is 84 divisible by 7? Yes. I'm going to, what's 84 divided by 17? It's 12. Is 84 divisible by 8? Nope. By 9? Nope. By 10? Nope. 11? Nope. Oh, there's my factor pairs. But remember, to get a negative product and a negative sum, one of these is going to have to be negative, and the negative is going to have to live with the bigger. Let's see if any of these work. What's the sum need to be? Negative 17. Here we have a sum of negative 83, negative 40, negative 25, negative, oh, there it is, negative 17. I don't need to go any further. Okay, so I'm going to go ahead and draw my box. Remember what we're doing. We're taking this polynomial, we're writing it as, there's my factor pair, negative 17k, we're writing it as 4k minus 21k. 4k minus 21k is negative 17k. I'm going to go ahead and draw the box for this. You're going to have 6k squared, 4k, negative 21k. It's a good thing I'm almost done because my pen doesn't want to cooperate here. Go ahead and finish it out. Should be a 4k. And in the last square, we put our constant term, which is our negative 14. All right, GCF for the top row is 2k. GCF for the bottom row is -7. For the first column, 6 and 21 are both divisible by 3, but there is a k that they have in common. And then 4 and 14 are divisible by 2, and I don't have a k in common, so there it is. And my final answer, I did not have a GCF at the beginning that I factored out. So my final answer is just the product of this binomial, which I get from the top of my multiplication box. Oops. Struggle is real when your pen's not wanting to work. And then 2k minus 7. And we're done. And we can check that multiplication. 2k times 3k is 6k squared. 2k times 2 is 4k. 3k times -7 is -21k. And 2 times -7 is -14. If I add up the two terms that are alike inside this table, I find out that I get back to what I started from, 6k squared minus 17k minus 14. So we have the correct answer. All right, last problem. We are going to look at r squared minus 25. Notice I just have two terms. What I need you guys to recognize is that 25 is a perfect square. It is 5 squared. What we have here is a difference of squares. There's the difference. Difference means subtract. And they're both perfect squares, r squared and 5 squared. So we need to remember that we have this formula that says a squared minus b squared will factor as a minus b times a plus b. And if you want to write them in the other order, the factors, you can. You can put the a plus b first and the a minus b second. It does not matter. Okay, so what I'm going to look at is I have this pattern up here, a squared minus b squared, but in place of the a, I'm going to put in an r. In place of the b, I'm going to put in a 5. Right? So everywhere I have an a, I'm going to put in a r. Everywhere I have a b, I'm going to put in a 5. That's the pattern. This is my a squared minus b squared. So we're going to go with r minus 5. Let me rewrite that because that looks awful. R minus 5 times R plus 5. There's my A minus B and my A plus B. But I don't have an A and a B. I have an R and a 5. But the pattern is the same. And there is our answer for problem number 12 in the video.